Okay, so we're looking at this DynamoDB service, which is one of AWS's database serverless services. And in particular, this one is classified as NoSQL. So I kind of gave the overview the last day, and we actually looked at playing with it from a Lambda point of view as well in terms of interaction. Some of the standout points-ish anyway about DynamoDB is there's a slight difference in the terminology that we use. Okay, we talk about tables. We don't talk about records. We talk about items. And an item has a primary key. That's a term we're familiar with. Primary keys in DynamoDB, anyway, there are two types of primary keys, simple and composite. In both cases, the primary key includes what's called a partition key, which we were talking about here. Partition key is really important because that, as I said the last day, that kind of determines which partition your item is stored in, effectively kind of where in the database your item is stored in. And we had all of that good stuff the last day, I think, really, so I'm not going to go back over it again. So, well, having just said that, simple illustration of the difference between simple and composite was this table, which is just storing orders. Well, we could decide to make the order ID the primary key, in which case it's a simple primary key, and the order ID actually is the partition key as well. So that was fine. That was one approach. The other approach was where our primary key is composite, and kind of arbitrarily we decided that the partition key part of the composite, sorry, just 1 second now. Sorry, no, there was just an interruption there for 1 second. Yeah, in this case, the primary key is a composite, and the composition is made up of the customer ID and the order ID, where we're using customer ID as the partition key. The benefit of this approach is that I could query this database along the lines of give me all orders for customer 1234. And there is a way of querying DynamoDB for that type of query. Whereas if I used this as my design for my table, I cannot actually query the database along that lines. I'd effectively have to read the entire contents of the database into my client side, Lambda in my case, and filter through all of the records, picking out the ones that are related to customer 1234. You must remember now that DynamoDB does not support the SQL query language, and querying DynamoDB databases can be a little bit of a stumbling block maybe for people initially, because it seems more restrictive than with relational databases, and it is in a sense. And we'll see that a little bit later on. Okay, moving on. I talked about the significance of the partition key the last day. So all of that is good stuff. Okay, I'm going to pick it up here, which is kind of linked to what I was just saying there about querying. So we're told here that in this slide that there are three types of actions that you can carry out against a DynamoDB table. One is just essentially CRUD behavior, which we call single item actions. And so yeah, there's a put item action where you want to write an item to your DynamoDB table. Get is a single item read, update is a single item update, delete is a single item operation. And obviously in the case of all of these three operations, you must specify the primary key, whether that be a simple or a composite primary key. So there's nothing unusual there. Now, here's the unusual part, I think, which is you can only run queries against a table that has a composite primary key. That's number one. By implication, you cannot run a query against a table that has a simple primary key. So you can only run a query against a table that has a composite primary key, and the query criteria has to be based on the individual parts of the primary key, that being the sort key and the partition key. Yeah. So that's what we're kind of saying here. And let's see now. It only suitable for tables. That's all right. I've made that point. Query results are always from the same partition. I mean, if you think about it, that is going to be the case. Your results are not going to come from across multiple partitions of your table. It'll always come from one partition, because as we'll see in a slide or two, the partition key part of a query has to specify the exact value of the partition key. You can't have a query along the lines of, I'm looking for items where, let's say if the partition key is a numeric value, where the partition key value is greater than 200. You cannot do that. You have to specify the exact value of the partition key. The sort key, all right, does allow you some flexibility in terms of how you specify it. And a query will always return a collection of items. There may be only one item in the collection, there may be none. There may be only one, but there may be more than one. And the third type of operation is what's called a scan. And that's essentially read the entire contents of the table. Right. So when you think about this now, right, that seems like it's awfully restrictive in terms of the kind of querying that you can do. And I've already made this point once or twice. It is. So you've got to think about your design of your DynamoDB table. This slide, we covered kind of this stuff that I asked. I'm just showing you the basics of, this is just showing you how to do a single item operation. So we're issuing a get item request against my table, and I'm telling it what table, and I'm specifying the full primary key. This table, as you might remember the last day, its primary key is a simple primary key. It just has the one part, the partition key, which was movie ID, if you remember. So we've covered that. So here I'm elaborating a little bit more on queries. And so I've already just said there a moment ago, so the query only applies to tables with composite primary keys, composite being a combination of the partition key and the sort key. And so for the partition key part of your query, you have to specify the exact value. So the only operator available to you is the equals operator. Okay, for the sort key though, you have all of these operators, and there are actually a few more as well, but if you take these ones, which are the simplest ones, so if the sort key is numeric value, then you can specify less than or equal to, greater than or equal to, between. Okay, they all make sense. Of course, if you specify equals, then you're only looking for one item, because you're now saying the partition key has to be equal to 1, 2, 3, 4. The sort key has to be equal to ABC. So that'll either match one item or no item. If you're using these operators here, then you're getting a collection of items. And that each item in that collection, though, will have the exact same partition key. And that's okay. If the sort key is a string, then you can use the begins with operator. There are a couple of other operators as well. I'm not mentioning them here, but like contains, and there are one or two others as well. Okay. So, so a query returns a collection of items where all of the items have the same partition key, but different sort keys. Now, if a query returns, you know, it could return a couple of hundred, a couple of 100, a couple of hundred items. You can actually do filtering of that collection, but the filtering does not happen at the DynamoDB side. It happens at the client side, in our case, at the Lambda side. So you might get the impression that filtering is something that will reduce the number of items returned back to your Lambda, but in fact it doesn't because it happens at the Lambda side. So if a query happens to return 100 items, then all of the 100 items are sent across the network from DynamoDB to your Lambda micro VM. The filtering is actually, you don't have to do the filtering in your code, in your Lambda code. It's actually taken care of by the DynamoDB SDK. Query response, there is a limit. There's a maximum of 1 megs upper limit on the amount of data that can be returned. So if a query you think is going to return more than that, then it's going to be cropped, on the DynamoDB side. You can specify a limit as to how many items you require in the collection. So if we take our example of a query results in a 100 items potentially being returned by DynamoDB, well, you can tell DynamoDB, I only want the first 20. And that may make sense depending on the nature of the query. So we're reducing essentially the amount of traffic between DynamoDB and your Lambda, or whatever your client is. You can do pagination as well of the pagination of the response between DynamoDB and your Lambda. This is just reinforcing what I've just been saying. So querying can only be based on these two attributes of your item. You cannot do any querying on the basis of the non-key attributes. The filtering is what you would be doing on these attributes here. But as I've already said, the filtering actually happens on the client side. So by way of example, and this is covered in the lab. So we've got this table. Let's suppose we've got this table that contains details about the different cast members in a movie. Okay, so a movie obviously will have multiple characters or cast members, and we have decided that the partition key for this table is movie ID. Okay, so there's going to be a number of items that are going to have the same movie ID because there's going to be more than one character in the movie. But we have chosen that as our partition key. The sort key I've decided is going to be the actor name. Yeah. So you can visualize that now. You can visualize the items in your table. Movie ID, actor name, and then maybe the name of the character, the description of the character, stuff like that. But this is our composite primary key. The rest we've had before. Here's an example of a query. So this code. This code here would be in your CDK stack. This code here would be in your Lambda. And we saw the last day that we talked to DynamoDB using what's called a DynamoDB document client. So that's what this guy would have been this variable would have been initialized to. We discussed that the last day. And what we're sending to it in this case is a query command. Last week we had a get command, so a query command. And the configuration of this query command, again, you've got to tell it what table are you querying from, what is the conditions associated with the composite primary key, So this is the expression that relates to the composite primary key. This part here is the partition key. So I'm saying movie ID, which is our partition key, as we said up here. Movie ID, movie ID equals, this is just a kind of placeholder, colon M. So it's a placeholder, as I said, and colon M gets its value down here. Now I'm hard coding it here, but usually you'd actually have some sort of variable here. And it's the equals operator. It always has to be the equals operator with the partition key part of your primary key. And over here, then we have the condition associated with the sort key. Now, because our sort key is a string, actor name, then one of the operators we can use is begins with. So we're looking for, and again, we've got a placeholder here. So it looks like we're looking for all actors in movie 1, 2, 3, 4, where the actor name begins with Bob. Yeah. Now, because of that restrictive nature of querying, how DynamoDB makes up for that restriction is via what are called secondary local indices or local secondary indices, LSIs. And a local secondary index is an index which uses the same partition key but a different sort key. Just before I get into that, another way, if I just go back to the previous slide, another way of explaining what's happening here, right, is that when you create a table like this, as well as the items being stored in the table, there is an index as well stored in the table. And we often refer to that as the primary, well, let's not use primary, call it the main index. Yeah. And the main index will have the full primary key value of an item and a kind of a reference to the item. You know, if I could just maybe visualize that for you. So if this is a partition, and we talk about individual partitions and all partitions are the same. If this is a partition, then we can imagine the main index looks like this. Okay, so we have the actual full item attributes, so the various items in our table. And we can imagine maybe that there's some sort of index down here. And each entry in this index will have the primary, the partition key and sort key of an item and a kind of a pointer to the actual item. Yeah, so that's our way of visualizing how data is actually stored in a partition. So when you create a table with a composite primary key, kind of this, and you start adding items to the table, this is how they are stored. The actual item itself is stored, and there's this index, which is a kind of a reference. But we know what an index is, right? So that's fine. Now, when you have a local secondary index, then what actually happens is the entire contents of the main index, we actually often refer to this as the main index, the all of it, not just this part. The actual, there's a full copy of the main index made for your local secondary index. So the data is actually kind of duplicated within the partition. And the items are repeated here. And there is an index part to your local secondary index. And it works the exact same way. But the thing is that in this local secondary index, the primary key is different from the primary key that's used in the main index. in the secondary index, the partition key is the same in both of them, but the sort key will be different. So if this is our kind of movie cast table, we had a movie ID and actor name as being the combined part of our primary key, composite primary key. Whereas, let's say in the local secondary index, I'm going to use movie ID and character name, the name of the actual character in the movie, as opposed to the actor name. Let that be the basis of my local secondary index. So the items here then, so well, yeah, that's it, right? So if I go back again to the slide, I'm saying that, okay, it only applies to tables with composite primary keys. That's the case. And LSIs are based on an alternative sort key attribute. So that was the kind of actor name versus character name that I was talking about there a moment ago. LSIs are stored locally, local to the partition, and that's kind of how I drew it in my makeup picture. They're actually in the same partition. The local secondary index and the main index are in the same partition. They have to be in the same partition because both indices are using the same partition key, and the role of the partition key is to determine what partition an item is stored in. There's an upper limit of 5 LSIs per table. And you can use the LSIs with your query. Okay, so we can now, if we take our movie cast example, we can now query our movie cast table on the basis of movie ID plus actor name or movie ID plus character name. I'm not sure if I said it in this slide or not, but you have to declare, I'm saying it here, right? The LSIs must be defined at table creation time. So once your table is created and there is some data in that table, you cannot add local secondary indexes subsequently, which kind of makes sense because the full local secondary index is being kind of constructed as you're adding items to the table. The attributes chosen, well, that's okay. That's very obvious, I guess. Each LSI entry is a projection of the table item. And so what I mean by a projection of it, if I go back to my picture, this is my main index, we were saying. This is the local secondary index. Well, you can, and this is an item, you can have the entire item projected down into the local secondary index, or you can declare that only certain non-key attributes should be projected down into the local secondary index. Maybe in the local secondary index, you don't want all of the non-key attributes to be stored. Probably, you would do that because maybe the querying that you're doing against the local secondary index, the results that are given back to your client doesn't need all of the data of the item. It only needs part of it. And you can control the level of projection between the two indices, or more than two if there are multiple LSIs. Okay, so if we take our orders table, this was our orders table that we had from earlier on, where the main index's primary key is comprised of customer ID and order ID. That's my composite primary key. Well, I could define a local secondary index which is based on customer ID as the primary key, customer ID as the partition key. It has to be customer ID because it has to match the partition key of the main index. But as a sort key, I've decided to use, what is it? The order date. Yeah. Now, if I have a local secondary index like that, that now means I can run queries like give me, and if you look at date here, date is, let's say date is entered as this. I could run a query like give me all orders for customer 1234 that begin with 2025. I'm not sure if I mentioned or not, but date is not a native type in DynamoDB. So these dates are actually stored as strings. And because in this case, my date is year, month, day, I think, then I could say the date string if it begins with 2025. So I can now run queries, as I just said, a query like give me all orders for customer 1234, which were made in 2025. Okay, I can't run that query against the main index, but I can in this one. Or I could have another local secondary index, which uses the order total value as the sort key. And that's going to allow me to run queries like give me all orders for customer 1234, where the order total value is greater than 200. And I get the matching items. And on this slide here, then I'm showing you, kind of repeating the points. These are all the different types of queries that I can now run against this customer orders table because I've got these two LSIs. Yeah, so that's where that's a typo there, I'd say. Oh yeah, sorry, there's a typo there. That should be. That's the fallback really. As I said, DynamoDB doesn't have the SQL query language, so it's these LSIs give you kind of make up for the lack of SQL support. Now, okay, that's orders, but in the lab and in the code here, I'm going back to my movie casts. So if we just quickly look through it, here's my movie cast table. Okay, movie ID, partition key, actor name is the sort key. This is how I define local secondary index. I'm essentially kind of adding this to the table configuration. You need to give each LSI a name, so I've called it role IX. And my sort key I'm saying is role name. I guess I should show you some seeding data so you know what movie cast items look like. So here's my seeding data. And here are some sample movie cast. So a movie cast item has a movie ID, actor name, role name, and role description. Yeah. So that's my data, and that's how it will appear in the table. Back to here. Okay, so I've added my local secondary index, and I do my seeding, which we're going to just skip over. And I've got a second lambda now. So this is the lambda that I'm going to use for talking to my movie cast table. Sorry, this lambda here. Yeah. And the lambda, I'm passing in the cast table name. I'm passing in the region. Now, the reason I'm passing in the second table is because I want to read from the movies table as well as the movie cast table. That's why I'm passing in both of them. We won't look at the reading from the movie table in the lecture, but you will be doing it in the lab. And if we just jump over to the management console and go into DynamoDB. And in tables, I have two tables, movie and movie cast. And the movie cast table, if we look at the data, it's exactly as I showed you in terms of the seeding. Okay, so that all looks good. Now, what I just so sorry, I've deployed this application, and my application has two lambdas. One lambda is for talking to the movies table. Well, in my case anyway, you don't have to link a lambda to a table. A lambda can talk to any number of tables it wants to. But in this example application, one of my lambdas is talking to just the movies table. That's the lambda we looked at the last day. The second lambda is talking to the movie cast table and the movies table, as it turns out. Both of the lambdas have a URL generated for them. That will allow me to trigger them from Postman in my case. Critically as well, of course, you do have to give the lambda the necessary permissions to talk to DynamoDB and to access particular tables. And that's what we're doing in these statements here. And the statements that I've just highlighted, they get translated into IAM policies, which we'll look at perhaps not today, but certainly we need to study those a little bit. Okay, so, and then I'm outputting just the URLs of my two lambdas. So I've deployed this, and if I go over to Postman, I'll just show you an example of querying the cast. So I've arbitrarily decided that there are three types of queries that I want to do against my movie cast table. One is where I want all of the cast for a particular movie. Another way of expressing that is I want all of the items in the movie cast table that have the same partition key, which is movie ID. The second type of query is I'm looking for only the items in the movie cast table that have the same movie ID, but the actor name begins with a particular substring. And the third type of query is I want all items from a particular movie where the role name or the character name begins with a particular substring. And let's just quickly look back at the seeding data again so we get a sense of the data that's in the table. So movie 1234, the actor name is Joe Bloggs. The role name is male character 1. Okay, that would never be a role name, but that's okay. It's just for the purpose of querying. Here's another cast, again for movie 1234. The actor name is Alice something. Character name, female character. Another one for 1234. It's Joe again, but it's Joe Clogs in this case. It's male character 1 is the role name. And okay, there's another one as well. So if we do our querying against movie 1234, so let's do just movie ID as being the, oh yeah, and I've decided that I'm going to use just the query string part of my request to express the kind of query constraints. So my query string here says movie ID equals 1234. So if I send that, I should get back all of the three characters in that movie. And I'm not getting anything for some reason. I'm going to do 1, 2, 3, 4. Did I click send? Okay, here we go. So I'm getting 1, 2, 3. Yeah, so I'm getting the 3 members. If I add on this part to the query string, sorry, not that part. Let's pick this one. Actor name equals Joe. So you can see I have 2 key value pairs in my query string. And if I send that, I'm getting back 2 matches, which is right. And I'll do one more, which is based on movie ID and let's say role name. And if the role name, let's say, begins with FEM so that would it should only have 1 match with the female character. Click send. Yeah, I get 1 match. If I change it to male, I should get 2 matches. Or anything that begins with MA, let's say, just leave it at that. And yeah, I get 2 matches. So that all seems to be working. Now, if we just quickly look at the Lambda that's doing all the querying for me, and we know now that the query string of the request, the query string of the HTTP request is where I extract essentially the partition key and sort key part of my query. So the Lambda is here. And you can see here where the query string is going to be available to us in the event object. We can look at the detail we've never looked at the detail of the event object so far. We will do that a little bit later on, but for now and now, we can just accept that there is a property called query string within the event object when the event object is actually a HTTP request. And that expression is going to return essentially an object with key value pairs. And the keys in the object will be the query keys, which in my case were movie ID and actor name or role name. And the values will be the actual values of the query string keys, if you like. So that's fine. Just checking to make sure that there was, sorry, now what am I doing here? Oh yeah, I'm checking that there is actually a query string, because if there isn't, I'm returning an error. Then I check to make sure I'm checking if there's a movie ID in my query string, because if there isn't, I'm going to return an error as well. Finally, I now know that there is going to be a movie ID, so I just grab that from the query string. So that variable is going to have, in my case, for example, 1, 2, 3, 4. And then I've just got, let's see, what am I doing here? Oh yeah, what I'm doing here now is I'm kind of setting up the command object that I'm going to be sending to DynamoDB. So for now, all I know is that I'm going to be talking, or I'm going to be sending the query to a particular table. So, and we know that I've passed in the table name from the environment variable to my Lambda, so that's okay. And here then I'm checking, well, I wonder which query did the user want. So I'm checking, was there a key in the query string called role name? If that's in the query string, so let's just step back now. If that is in the query string, and if we go back to Postman, it is in this query string, for example, then it means that we are going to be executing the query against our local secondary index. What do I mean by that? We're going to be running the query against this particular index here, not the main index, because the main index was based on in the main index, the sort key was actor name, but I don't have the actor name in this query. All I have is the role name or part of the role name. So I need to run my query against this LSI, which I've called role IX. Yeah. So let's just keep that in mind when we go back to our Lambda. So if role name is in the query string, then what I'm doing here is I'm adding some more information to my command object. Okay, I've initialized my command object here, and all I've said is I know the table name at this stage, but now I know a little bit more. So I am adding I'm telling it which index to use in the query, role IX, and I'm giving the full key condition where movie ID equals that. And you can see the sort key condition. The sort key is based around the role name attribute, if you like. And here are the actual values for in my key condition, colon M. And, colon M is just essentially kind of a variable name. It can be anything you want it to be, right? And similarly over here, what did I use? Colon R, it can be anything you want it to be, and it doesn't have to be a single character. But here I'm kind of giving the actual values to those key condition variables. And okay, so that's fine. However, in the else part of the if statement, I'm checking, well, else if the actor name is in the query string, then we have to set up our command slightly differently. Our key condition, you can see I'm not specifying any index here. I did specify an index here, which is my local secondary index, but I'm not specifying an index here, and the default is the main index, which is the one that's based on actor name. I'm expressing my key condition and I'm giving the actual values. Okay. The third option is where the user didn't specify a role name or an actor name. It was only the movie ID. And in that case, again, my query is going to be based on the main index. But if you see my key condition is just about the partition key, the movie ID. There's nothing related to the sort key. So this one here is going to return all of the movie cast items for a particular movie. Eventually, then I actually run my query against DynamoDB. So I'm sending it, in this case, I'm sending it a query command. And this is the full configuration of the query command, what we were setting up here, or here, or here. Okay, so, and again, you will be doing this in the lab, so you can study it in a little bit more detail. There's some other stuff going down here, which I'm not going to get into. So other than maybe no. Okay, that's where we do it. And the response that comes back is going to be an object, and that object is going to have a property called items, plural, and that's going to contain the actual items that were matched to query. Right. That's all about LSIs. I have a link here to a YouTube video. It's quite short actually, but it kind of explains some of the stuff that I've talked about there, like as in main index, local secondary indices. So if you wish, you can have a look at that. If I now go back to stuff that I skipped over, so which was way back here. Uh, sorry, no, back to here, back to the Lambda stuff actually. And before I do that, I should just say that in relation to the lab, let's bring up the lab. So now everybody should be able to walk through this entire lab. You may have started it already, but there's a section here which I've kind of labeled as new as in the sense that this section wasn't in the lab last week. And in this section, as you can tell from the title, you're looking at queries and LSIs. And it's quite long actually. And there's an exercise at the end to test your understanding of what's going on. Okay, so you can work through that in your own time. Now, when we were talking about lambdas, there were a couple of slides that I skipped over. So one is this slide here called the execution role. So every lambda has an execution role. It's essentially an IAM role, and it controls what other services the lambda can interact with. As you know from your automated cloud services, IAM kind of controls everything. If a compute resource doesn't have the necessary IAM permissions, then it can't do anything. And the same is true of a Lambda. A Lambda can't really do anything other than console log to CloudWatch logs. It can't do anything else. So the execution role part of a Lambda controls what it can do in terms of talking to other services and accessing other resources. And of course, that's of interest to us because we want our Lambda at this stage anyway to be able to talk to DynamoDB and to access a particular table. There are some some predefined IAM policies specifically targeting the Lambda service and Lambda functions, and I'm mentioning some of them here. But of course, you can roll your own IAM policy. The best practice is that every Lambda in your application has its own execution role. It's considered not a good idea to share the same execution role. And again, an execution role is just an IAM role. It's not a good idea to have to share the same role across multiple Lambdas, because if you happen to want to give some extra permissions to one Lambda, you'll accidentally assign it to that shared role, and now all of the other Lambdas that use the same role will have those extra permissions. And we know that's not a good practice. Now, if I go back to the management console, and if we look at one of our Lambdas, we have two Lambdas, and both of them are talking to DynamoDB. So this is the movie Cast one, which we were just looking at. And if we click on the configuration part and the permissions part, here we can see execution role. And there is a role that was actually created for our Lambda. Now, there was nothing in my CDK stack, though, that talked about creating a role for my Lambda function. And so this is a really good example of the kind of beauty of the CDK framework. The CDK framework actually added in the necessary CloudFormation code, CloudFormation template code, to tell the CloudFormation service to create an IAM role specifically for this Lambda. Okay, and it looks like the name it gave to the role kind of is a combination of the stack name, the Lambda name, and a hash value. So if we click into that, we're now inside on the top left here. You can see we're now inside in the IAM management console. And here we can see that there are two policies attached to this role. This policy here is a kind of default policy that's assigned to every Lambda. And it's the policy that allows it to talk to CloudWatch logs. This policy here is a custom policy that was generated by the CDK framework for our particular Lambda function. And this policy, if we actually go into it and look at the detail of it, this is the policy that gives my Lambda the power to talk to DynamoDB. You've seen these policies last year in the automated cloud services. So you can see here, like these are the actions that are allowed, and they all relate to DynamoDB. Now, where did this policy come from, though? And the answer is, if I go back to my stack, it's these lines here. So let's see which one in particular. This line. This line gives the movie-cast Lambda read permissions on the movie-cast table. And that single line caused the CDK framework to generate the necessary CloudFormation template code to tell CloudFormation service to create the policy for me. And that's a really nice example of this kind of imperative code generating our declarative CloudFormation template. And also it's just one line of imperative code, but as we know in CloudFormation syntax, CloudFormation template, YAML syntax, there will be multiple lines generated, would need to be generated in order to create our policy and attach it to the Lambda. So that's kind of neat, right? A neat kind of aspect of the CDK framework. And maybe if I wrap up with this, if I do this, right, if I take this out, now I'm going to take out this line as well because this is giving the same Lambda permissions to access the movies table. But if I take both of those lines out and I redeploy, and we'll try and run our query, and of course it isn't going to work. While that's working, I'm just going to switch back here, go to CloudWatch. I kind of think it's always a good idea to clean up your logs just to make sure that you're not looking at old logs, because when you're debugging, obviously you have to make sure that you're looking at the most recent logs. So I'm just going to clean up everything. Okay, and my deploy has completed. Now my functions will have the same URLs. So if I go back to Postman, and I try and run any of my queries, let's run the same query that we're on. And of course, it doesn't work. And if you look at it's an access control issue, which is a standard way of, it's the Lambda service now that has generated, is it the Lambda service? No, it's actually my Lambda function has generated this exception when it tried to run the query against the database. And access control means that the Lambda doesn't have the necessary permissions to access the other service, DynamoDB in this case. And if we look at the log, now the Lambda has run, so there will be a log stream for it. If I do a refresh here, I should get a log group. Is it going to behave for me? It's not. Okay, it's I think AWS is telling me to stop the lecture, I guess, but there should really be a log group here. So I'm going to have to pick up the story the next day and we look at that because it is an important kind of debugging feature for you to understand. Okay, that's going to be it for today. And you can now, as I said, you can now complete the lab in question. And I'll turn up at the lab class tomorrow as usual. That's all for now. Thanks. Bye-bye.